Fiber rope is one of the rigger's most valuable tools. In rigging, it has a variety of uses and is generally referred to as line, yet the construction itself is called rope. There are many different sizes and types, designed to do numerous rigging jobs. To determine the size of fiber rope, measure around its circumference. This rope is 6 inches around, therefore it's called 6-inch line. This fiber rope, for instance, is suitable for docking a ship, where lines must be strong, yet flexible and easy to handle. Fiber rope is also used for slinging certain types of loads, rigging boat falls, and flag halyards aboard ship. Regardless of size, type, or use, the life and serviceability of rope depend upon the care it receives. This type of fiber rope, sometimes used in rigging life floats, is called sisal, a variety of Central American hemp. To a great extent, sisal has replaced the more familiar manila fiber rope. In both sisal and manila rope, 3 strands are twisted to make the finished rope. Each strand is made up of 3 yarns or threads, and the yarns or threads consist of many fibers. Sisal rope is well suited to this type of manufactured rigging. However, jute rope is also used when sisal is not available. Fiber rope is also used for boat falls on lifeboats. This particular kind of fiber rope, which is obtained from the stalk of the wild banana plant, is called manila. Its construction is like sisal rope, but it is preferred for lifting weights and for running gear where durability and strength are needed. It is also more flexible and not as harsh on the hands as other rope. When rope is used as running gear, care must be taken to see that the rope is the right size for the shiv groove. This avoids wear and preserves the life of the rope. Half the diameter of the rope should be supported by the groove. The groove must be smooth so that rope fibers are protected against excessive wear. The life of fiber rope depends upon the care it receives. When making an eye, for instance, the rope is threaded through a thimble and the strands separated so the ends may be tucked into the twisted rope. This protects the rope against excessive wear. A pointed wooden tool called a fid is used to tuck in the loose ends. With tucking complete, the ends are trimmed. Small line is then wound between the strands to smooth out the splice. This operation is called worming. Wrapping the rope in this manner, called parceling, helps to protect the rope from weather and wear. Tallow waterproofs the parceling. To complete the splice, serving is applied with a serving board. Marlin, sometimes called small stuff, is used for serving and seizing. In the manufacture of marlin, a touring process is used to make it waterproof. Note how the serving board pulls the marlin tight around the splice. Serving adds to the neatness and keeps the splice from pulling out. Another type of rope of entirely different construction is the unfinished flax rope, or treated cotton line used for signal halyards. This type of line is braided instead of twisted and has a hollow center, which makes it very flexible. To make an eye in this type of line, the tapered end is bound with waxed sail twine and threaded through the eye of the snap hook. Then a pricker is forced through the hollow center, opening the line so the tapered end may be pulled through. Weight or effort applied on either end tightens the connection. To make a strap for lifting loads, the ends of the rope are spliced together with a short splice. First, the strands of rope are unlaid. Then the ends of the strands are seized to prevent the yarns from unlaying. The bitter ends are now placed together. A fid is used to tuck in the loose ends. After the tucking has been completed, the ends of the strands are divided, and by using a rigger's palm, they are sewed to the rope. This operation is called dog earing. When the strap is used to lift a load, this strengthens the splice and helps to hold the strands in place. The strap is choked off around the load in this manner. A fiber strap is especially suited for lifting radio equipment. A wire strap might magnetize the machinery or damage the case. Chafing gear is placed wherever fiber rope comes in contact with sharp edges. This protects the rope, giving it increased efficiency and longer life. Fiber rope is more flexible than wire rope. Note how this fiber strap grips the load. Lifting a steel shaft is a typical slinging job where fiber slings are used. Slings with an eye splice on each end are choked off around the shaft and will not slip or scratch the metal surface. Care to avoid sudden stress in lifting helps to prolong the life of the rope. Various sizes and types of fiber rope are made for specific jobs. This rope will be used to guide a ship into dry dock. To uncoil fiber rope, reach inside the coil and take the end from the bottom. Handling in this manner prevents kinking. The rope is measured to correct length and seized before cutting. Seizing the rope prevents fraying and subsequent loss of material. After the line has been cut, one end is made into a 6-foot eye. The opposite end is called the bitter end. A bend within the line is called a bite. With the eye splice complete, the line is coiled and then tagged to indicate its size, type, and the job for which it is intended. In docking, Lines vary in size according to the type of work to be done. The hauling in line is larger than docking lines because it is subject to greater strain. A snatch block protects the line from the rough edge of the dock. It is also used as a fair lead to aid in placing the line on the capstan. Since fiber rope stretches under a load or strain, overload should be avoided. The line should be laid around the lower part of the capstan and taken off from the top. If the line is slacked off, it will drop down, crossing over itself, making a riding turn. This fouls the line so that it cannot be released immediately. To bring a ship into dry dock, heavy docking lines are employed. A smaller line, called a heaving line, is used to haul the docking lines aboard. Heaving lines not only act as messengers in bringing docking lines aboard ship, but also help keep the docking lines dry. The lines are hauled aboard through chocks, which protect the rope against the sharp edge of the ship. They are secured to bitts on deck. The opposite end of the line is secured to cleats on the dock. As the ship moves forward, docking lines are shifted from cleat to cleat. The line is always placed around the end of the cleat opposite to the direction in which the ship is moving. When placed around the cleat correctly, it can be released quickly. Care is taken to keep the lines clean. Dirt or sand within the rope will cut the fibers, thus shortening its life. Whenever possible, fiber rope should be protected from the weather. Fiber rope should be thoroughly dried before storing. This prevents rotting. Dry lines, when not in use, are returned to the rope locker. To summarize, fiber rope has many uses in the Navy yard as well as aboard ship. To determine the size of fiber rope, always measure the circumference. Avoid kinks. Uncoil fiber rope from the inside and bottom of the coil. To prevent unlaying, seize all fiber rope before cutting. Protect the rope fibers. Select the right size rope for the shiv. Examine the shiv groove. Make sure it is smooth. Splices should be served with marline. This protects the splice against weather and prevents the strands from pulling out. Select the right rope for the job. On flag halyards, for instance, a braided line is used because of its flexibility. Fiber rope is ideal for slinging certain types of loads, especially when the load might scratch or damage easily. Time spent in frequent inspection and repair will be well repaid by greater efficiency and longer life in your fiber rope.